What are Microsoft's recommendation for modern web .NET application? Everyone, my name is Vikas Kearney. I have 20 years of experience in IT industry. I am TOGAF certified architect and I'm very passionate about software architecture. Do subscribe to my channel for regular updates. Nowadays, we are using agile methodology. We don't have too much time for architecture. Architecture evolves over the time. I was looking for are there some existing software which especially for .NET technology which we can use and maybe evolve it later. I was looking for Microsoft architectural recommendation and sample application. So I found this architecting modern web applications with ASP.NET Core and Azure. So let's review this ebook together. It's a very good it's a very nice read. Let's let us review architecting modern web applications with ASP.NET Core and Microsoft Azure. This is architectural guidance from Microsoft. So when do you need .NET Core and ASP.NET Core framework in your application? When you need cross-platform support, you are going to use microservices. You need to use Docker container. You need high performance and scalable requirement. You want to deploy side-by-side version on cloud platform. So what are the characteristics of modern web applications? So this is modern applications need to be hosted on cloud, need to be scalable. This is a sample application given by Microsoft. What are the good practices if you want your application to be deployed, to be cross-hosted, scalable? So today applications need to be cross-platform. You want to run on different platform other than Windows. They should be modular, should be easily supported. And right now, single page applications are very popular. You don't want to spend too much time on deployment. They should be easy to deployment. Here's Microsoft gives recommendation when you should use simple application instead of service single page application. If your application means one thing, it says you should use the not single page application when your developers don't know JavaScript or TypeScript. You should use single page application when your users are expecting a very rich in experience from internet. In my experience nowadays the people expect a lot from the websites. Here it goes more into details when you should use single page application and when you should use traditional web applications. Here it's a very nice metric. Okay, if your application requires team familiarity with JavaScript, traditional web are good. Single page will require not lot of JavaScript knowledge. uh, Basically you need some complex logic, so again single page is good. But if your application is very easy, publishing may be good. So what are the common good design principles? Separation of concerns, like your business logic should be different, your data logic should be good. Encapsulation is when the component is hiding its complexity from its client just know how you need to calculate some logic without knowing the details. Dependency inversion, it's very nice. Microsoft has put so much focus on dependency inversion does. So here is telling a where we are not using any dependency. Class A is tied uh, tightly to class B to class C. Here it shows example what the dependency injection gonna look like. Basically, you are coding to the interface, not the real class. Single responsibility. This is the principle we should follow. The component should have only one reason to change. If if you are making your component is changing too much, like if you are making business logic changes to data components, there's something wrong there. Don't repeat yourself. So one of the conference I went to Microsoft, he joked that the common principle is, one of the most popular principle is cut and paste. And yeah, your classes should not know persistence, means your business logic should not know. Bounded context is a concept from domain driven design. Basically, it's a way of separating the logic into different context. And so application architecture, what is monolithic application? Basically, monolithic application has everything in one project. Monolithic application has everything involved, all one project, all in one application. So Microsoft is giving you the example. There's one solution, one project, and one project has everything. So what are layers? What is when your complexity increases? So one way, easy way of breaking your application is into layers. This is simple layer. You can have user layer, business layer, and the data layer. So it's just showing you how you can, how simple is that one. If you monolithic application, you just deploy in one click. So here is you showing the Azure deployment architecture. You put your stuff in staging, somebody reviews in the staging and push it to production. So basically in Azure, you have Azure Active Directory for authentication, which is infrastructure services. They are providing you databases, storage account, and different uh, web container, all those other services. So clean architecture. What is clean architecture? When you use domain-driven design and dependency injection, so this you will have a common architecture. This architecture has been given a lot of name. It is also called as onion architecture or clean architecture. I'm reviewing a clean architecture book from Uncle Bob. I was not aware that clean architecture is a common name. I thought Uncle Bob came with that name, clean. So here's the diagram. In clean architecture, uh, at the core, you have business logic, service application core, entities, and your UI and infrastructure is on the outer layer. So here is showing you the user interface uses application and infrastructure. Basically, user interface should be tied to infrastructure interfaces, not using the real implementation. So this way, your application core should not be aware of the infrastructure details. Here it's giving the ASP.NET Core architecture. So as ASP.NET Core Web App has controller, view models, ASP.NET Core identity, other filters. An infrastructure project, we have in-memory database cache, entity framework, Azure Service Bus Accessor, SMS services, email, other web API clients that uses third-party clients, and it may be accessing infrastructure project, may be using data source. And here is the application core project where we have aggregates, interfaces, POCO, business services. So we can see application core does not depend on the infrastructure. So here domain service, we have infrastructure, integration test should be written against infrastructure. UI should not have any direct dependency on types defined in the infrastructure project. It should be coding against the interfaces. So for monolithic applications, ASP.NET Core, infrastructure and user interfaces all run in single application, single process. There are no logical or physical separations. So we can see ASP.NET Core web applications have everything inside one, infrastructure, ASP.NET Core, email services, uh, everything is in one solution, and that solution is accessing data sources, third party services, and identity providers. So we can see how what is the difference between that clean architecture and monolithic architecture. So how we organize code in clean architecture. So what are the, this is application code types, infrastructure types, we have databases, and what are the different elements are in UI layer types, controllers, filters, pages, ASP.NET, a lot of ASP.NET core MVC elements for simple monolithic applications. It is talking about monolithic applications and containers. If you are deploying in the Docker, how your monolithic application should be deployed. So it's a diagram here. We'll quickly go through this one. We'll have another session about deploying on the Docker, Azure. So we'll quickly pass through this. We know HTML, CSS, JavaScript, legacy web apps with jQuery, Angular single page applications, which is very popular, and React. React is this is interesting. Unlike Angular, which is a MVC pattern, React is only concerned with views. It's not a framework, just a library. So if you are building SPA, you will need additional JavaScript libraries, React. This is virtual DOM. So this is one of the feature given by React, virtual DOM, which you can increase the performance and testability. It's also usual how it works in HTML. There's extension of JSX, so we can see it is using the mockup language, and within mockup the language, you have some different scripting language. Again, it talks when you should use single page application. Here quickly we'll go through the MVC page architecture. It's talking about if you're using MVC, not single pages. Working with dependencies. So dependency injection is such a important concept that Microsoft has built-in dependency injection inside the ASP.NET Core framework. I will quickly go through all this MVC and dependency injection. So the framework of talking to get more interesting. So here is giving the security recommendations. Domain driven design. Domain driven design is an agile approach to build software that focuses on business domain. So a lot of time business people are talking about business terms. They are talking about invoices, payments, and we are talking about databases, objects. So domain driven design is about coming up a common languages which business people and the technical people understand. We cannot talk into different languages. So it talks what are the common terms in domain driven design. So domain driven design does employ a lot of patterns. Repository is for abstracting persistence details. Factory pattern for creating objects. Services, command, and when you should apply DDD. So if you work for a financial, medical, where you are talking different kind of expert domains, definitely you should be talking about domain driven design. Domain, you should have a common language. A business, technical people should be talking business language here, and it's talking about entity framework. So it's very, there's a Dapper uh, ORM, and which is geared towards performance. I'm working on an application where database performance is one of the key concerns. So I'm going to evaluate Dapper. Dapper, the entity framework gives you a lot of additional advantages. So here an interesting entity framework core. Oh, entity, they have built a entity for framework core. So it provides you some additional advantages. Uh, mean link to SQL translation, which it's easy, and second is tracking entities for update, and which can be turned off, but it makes entity framework core slower. So if you are concerned about performance, you should be using Dapper. SQL or no SQL. So it's saying MongoDB is good to store entire object graph kind of thing. So I have a situation where I am storing a big XML document in SQL Server. Maybe I should convert into JSON format, and maybe we can use on MongoDB. Right, this database it slows it down a lot, and it's talking about other places. Caching is very very important. It increases the performance of application. So it talking about .NET caching, and it seems that they have some enterprise level caching mechanism called Redis. So I let's go back to caching, and because caching is so important. So data caching, rather, I think this must be the distributed caching. And distributed caching has its own advantages. It's available across servers. Here we are talking about automated test, unit test. A unit test is single part of your applications. I like Uncle Bob definition. He says unit test is fastest test, integration test is slowest test, functional test. To me, that are acceptance tests. They are written by. So it shows the way you will have lot of unit tests when very few. They have given a very good recommendation when you should test. So if you have lot of if-else logic, you should be testing those if-else logic. And if you have happy path, your code is testing for errors. So you should be testing all the errors in the applications. So how you organize your test project? Should object has a test, or it should be outside? I think the good compromise is having outside. That's the common approach I have seen. You have one for each project. You have a one test project. Here it comes with the naming. I think naming is very important. So if your class has a catalog controller get image has calls image service with IT, so your test should have should. So it now we see catalog controller get image should call image service without. Unit testing, it gives you some examples. How can you unit test ASP.NET Core? It's giving you the code examples. Deployment process for Azure. We'll quickly go through. Maybe I can have a different video for going through this one. Visual Studio gives you ID for deploying on Azure. Uh, so it seems you can define your own CI build process in there. And here is the workflow, end-to-end deployment into, and there's a dev environment and application code repository. You're building the code and deploying it. So coming to the last, hosting, they are giving you more details on hosting. So we can have another session. So it was a very nice document. I enjoyed reading it, and there were some good practices. And not only core, I think we can use it for if even if we are not using core, there are a lot of techniques. I really enjoyed reading the Microsoft recommendation for modern ASP.NET Web Core. I think they have taken a lot of good practices, industry practices. Dependency injection was very popular in Microsoft .NET architecture community or even Java community. So it was very good to find out the clean architecture, the emphasis the document has put the current good technologies like AngularJS, single point pages, and also on the other good practices like dependency injections, domain driven design. So it was very good read, and it's a very good starting point if you are starting new. You don't have existing architecture which you can reuse. So it's a very start, and you don't want to struggle initially on the architecture level. You want to deliver something fast. I think I really like the Microsoft recommendations ebook. I look forward to reading other books. So if you are interested in the architecture, do subscribe to my blog, my channel. I will be putting more videos.